Tutorial number 4, question number 1. A 54 kilograms pilot flies in a jet trainers in a half vertical loop of 1200 meter radians. Knowing that the normal force at sea exerted on the pilot by the seat is 350 newtons, find the velocity of the jet trainer at sea. Apparently, it is curvilinear motion. And what we have is the mass of the pilot, which is 54 kilograms, and also the radians is equal to 1200 meters, and also the acceleration in tangential direction is constant. Let's do the free body diagram to the pilot. It has the force from the seat, which is equal to 350 Newton, and also the gravity of the self, which is 54 times standard gravity. And also we define this as the normal direction, and also this as a tangential direction, if you want. So we have the force in normal forces in normal directions is equal to ma normal. So it'll be 350 plus 54 times 9.81 is equal to 54 times it's equal to v squared divided by radians, which is 1200 meters. So we can get the velocity of the pilot, it will be equal to 139.8 meters per second. Question number 2. At the instance under consideration, the cable attached to the card of mass m1 is tangent to the circular path of the card. Its upward speed of the cylinders of mass m2 is v2 equal to 1.2 meters per second. Determine the magnitude of acceleration of m1 and the tension T in the cable. First, we have the acceleration, the velocity of m2, which is equal to 1.2 meters per second, and also the ratio is equal to 1.75 meters, and also m1 is equal to 0.4 kilograms, m2 is equal to 0.6 kilograms. The beta is equal to 30 degrees. What we need to find is the acceleration of the mass m1 and T tension from the cable, and also velocity of the mass 2. What we want the maximum value of it. Let's do the free body diagram of these two mass. For m1 we have a gravity which is 1 g, the support from the path which is n, and also the tension from the cable T. Right here we can define our tangential direction and our normal direction. By the way, right here is a beta. For m2, it was supported by one pulley and two cables, and it have gravity. So we can define this direction as our y. So when we see a pulley, we can consider the length of the cable are constant. So we define this as S2, S1, and this is S2. We have S1 plus 2S2 is equal to constant. Take the derivative of whole equation with respect to time. We have V1 plus 2V2 is equal to 0, and A1 plus 2A2 is equal to 0. We set it we set this as our equation number 1. And also the sum of force in tangential direction is equal to ma tangential. So we have negative t plus m1g sine beta is equal to m1a1t. So as we can find that this a1 right here is actually equal to the acceleration of the mass in tangential direction. So it's equal to a1t. Here's our equation number 2. So in y direction, it's equal to ma. So m2g minus 2t is equal to m2a2. Here's our equation number 3. Right here we have 3 unknowns, which is a1t, a2, and t. We have 3 unknowns and 3 equations, so we can solve it. a1t is equal to negative 1.784 meter per second square. a2 is equal to 0.892 meter per second square. T is equal to 2.68 newtons. When we need to find the maximum speed of m2, we will see the support from the path is equal to 0 when the velocity reaches maximum value. So we have n reaches to 0. So we have the force in normal direction is equal to ma normal. So m1g cosine beta is equal to m1. The normal acceleration is equal to v1 maximum square over ratio. So v1 maximum is equal to gr cosine beta 1 over 2 is equal to 9.81 times 1.75 times cosine 30 degrees, which is equal to 3.86 meter per second. So V2's maximum, according to this equation, is equal to 1.928 meter per second. Question number 3. Each tire on the car can support a maximum friction force of 2,500 newtons. What we need to find is the total stopping distance S. The brakes are first applied at point A, with the initial velocity of 25 meter per second. So what we have is the mass of the car is equal to 1350 kilograms, and also the maximum braking force it can support is equal to 10,000 Newton, and also initial velocity is equal to 25 meter per second, and also delta SAB is equal to 10 meters. What we need to find is the braking distance S. As we can see that from A to B is a rectilinear motion. Let's do a free body diagram. Here's our x direction. It has a force of 10,000 newtons. So we can see the force in x direction is equal to max, and -4 times 2,500 is equal to 1,350. Acceleration, the acceleration is equal to negative 7.407 meter per second square. Because it's rectilinear motion, we have VB square minus VA square equal to 2A delta S. So VB square is equal to 2 times negative 7.407 times 10 plus 25 square. So VB is equal to 21.84 meter per second. When the car is on the curve, we can define our coordination. Here's our tangential direction. Here's our normal direction. And they have a force, the braking force, which is 10,000 Newton. So F is equal to MA total. Right here is a braking force, so we have a total is equal to 10,000 divided by 1350, which is equal to 7.407 meter per second square. So A total equal to AN square plus A tangential square is equal to V square R square plus AT square. So AT is equal to, by definition, AT is equal to dV divided by dt. We can expand it by the chain rule, so V ds and ds divided by dt. So this part is equal to V, this part is equal to V, so we have V dV ds. So AT is equal to negative square root A total square minus V rho square is equal to V dV ds. After we rearrange it, we can ds is equal to V dV divided by negative square root A total when we take the integral of the equation. So S is from 10 to S. V is from VB to 0. We use the substitute rule right here, so we let x is equal to v squared. So we have s minus 10 is equal to negative rho from vb squared to 0 dx divided by 2 to rho squared a total minus x squared. So we have s is equal to 10 plus rho over 2 sine vb squared rho a total, which is equal to 47.4 meters. Question number 4. The 5 kilogram block starts at rest on the inclining assistant as shown below. A non-constant force F is applied to the block. What we need to determine is the block speed when S is equal to 0.5 meter. Because there's no friction, so we consider use the energy conservative to solve this problem. Although there's an external force applied on the block. So we have T1, T2 plus V E2 plus Vg2 is equal to T1 plus Ve1 plus Vg1 plus E122. So Ve means the elastic potential energy and Vg means the gravitational energy. T means kinetic energy, and U means the work done during of the external force. So we can solve this first. Equal to FDS. So it will be from 0 to 0.5 S plus 100 ds. After solve it, we have 56.25 joule. And the kinetic energy will be 0 because it starts at rest. And the gravitational energy is also equal to 0 because we set this as our reference. And because the whole system is in equilibrium, so we can do a free body diagram right here. It's Newton, here's our gravity, and here's our Ks. So the force in x direction is equal to 0, which is equal to Ks minus mg sine 30 degrees. So S is equal to 0.245 meter. That is the displacement of the spring at the first time. So we have VE 1 is equal to 1 over 2 Ks squared to 2 times 100 times 0.245 square, which is equal to 3. And what we still need to calculate is the VE2, because we assume that the spring is compressed at the first time, but after that, after the displacement, it will be expanded. So the new displacement will be 0.5 minus 0.245, which is equal to 3.25 joule. And VE2 is solved. So T2 is equal to 1 over 2 mv2 square, which is equal to 1.5 v2 square. So we have this, we have this, we have this, we have this. So we have Vg2. Vg2 is equal to mg delta H equal to mg g delta S sine 30 degrees, which is equal to 5 times 9.81 times 0.5 times sine 30 degrees, which is equal to 12.26. So we can put all these parameters into our equations. We'll have T2 is equal to U1 minus 2, 1 to 2, plus VE1 minus VE2 minus VG2. So we have 56.25 plus 3 minus 3.25 minus 12.26 is equal to 43.74. So V2 is equal to square root 43.74 divided by 2.5 is equal to 4.18 meter per second.